For numbers 13 and 14, where it asks us the end behavior, we really have to know how the end behavior looks. So end behavior is like what happens on the graph when it's at its far extremes on the left and also on the right-hand side. So all polynomial graphs will look one of 4 different ways, and we can determine the end behavior based off of those 4 different ways. Here's a really easy table that you can construct on your quiz to tell what the end behavior is going to be. These can be really easy points if you just remember this one little diagram. So to find the end behavior, you need to remember 2 things. You need to know the degree of a polynomial, and you also need to know the sign, or whether it's positive or negative for the largest term in your polynomial. So when we look at the degree, we're trying to tell if it's going to be an even degree or an odd degree. And for the sign, we're telling if it's either positive or negative. Because here's how it works out. If we just draw this little table with 4 columns, or 4 little entries right over here, if we have an even degree, like if the degree of the polynomial is 2 or 4 or 6 or 10, then that means that the end behavior on the left-hand side of the graph, it's going to be pointing up, and on the right-hand side of the graph, it's going to be pointing up. Or they're both going to be pointing downwards on the left and the right-hand side of the graph. A bunch of stuff might happen in between the graph, but the end behavior really just talks about like how the graph looks on the left-hand side and the right-hand side. And we'll even get out a graphing calculator to graph the whole thing out to see how it looks when x gets really big and really big and positive, really big and negative. Anyways, so to complete this diagram. If you have an even degree and a positive lead coefficient, that means that the end behavior is going to be up on the left-hand side and up on the right-hand side. And then a bunch of other crap might happen in between, but you only need to care about the fact that it's going up to up. All right. If the degree is even and the lead coefficient is negative, then that means that on the left-hand side, the graph is going to be pointing downwards. Then some stuff might happen in between, and on the right-hand side, the graph is going to be pointing downwards. So this is where we have a down to down end behavior, or down on the left-hand side, down on the right-hand side. If the degree is odd and a positive lead coefficient, the graph starts by pointing downwards, then some stuff happens in the middle, and it ends by pointing upwards. So this is what we call a down to up end behavior. And then the last one is if the degree is odd and the lead coefficient is negative, then the graph starts on the left-hand side by pointing upwards, and then it ends the graph by pointing downwards on the right-hand side. We call this an up to down end behavior. All right, so let's go ahead and find the end behavior for number 13 and number 14. So we need the degree and also the sign on the lead coefficient. So the degree for this one is going to be the highest power on any of the exponent variables. So that's going to be x to the third, and in particular the 3 right there, because it's bigger power than any of the others. So our degree is going to be 3. Now I just need to tell whether or not this term is positive or negative. Now, since it's just regular old x to the third, that means it's positive. So we look on our chart. The degree is 3, so that's an odd number. So that means that we have an odd degree. And then it's a positive sign. So positive sign, odd degree means that the end behavior goes from down to up. Or if you want to graph it out, it's down on the left-hand side, up on the right-hand side, like that. All right, for number 14, the degree is going to be from this term, negative x to the 4th, because 4 is the biggest power, so the degree is 4. And then it has a negative lead coefficient. So that means that if it's an even number like 4 and a negative lead coefficient, that means that the graph points from down to down. So it's going to look like this, down on the left, down on the right. And that's it. So that's end behavior, and all you need is the degree and the sign.